The crane on top of that skyscraper was never lifted up there. It climbed there by itself. And if the building isn't finished, it's still growing right now. That's not an exaggeration. There is no machine on Earth that placed that crane at that height. Nothing lifted it. No helicopter. No bigger crane. Nothing. It got up there alone, one piece at a time, by grabbing chunks of its own body and stacking them underneath itself. You've seen these things your whole life. Every city skyline has them. Those tall yellow towers with the long horizontal arm, slowly swinging steel and concrete over your head while you sit in traffic. You've probably never thought about them for more than 2 seconds. But hidden inside that tower is one of the cleverest tricks in all of construction. Because tower cranes have a problem that sounds like a riddle. Here it is. A crane exists to lift heavy things to high places. But the crane itself is a heavy thing in a high place. So what lifted the crane? Think about it for a second. If you needed a bigger crane to install every crane, you'd need an even bigger crane to install that one. And a bigger one for that one. You'd end up needing an infinite chain of cranes, each one taller than the last. Cities would be impossible, so engineers cheated. They designed a machine that assembles itself in mid-air. Here's how the trick works. A tower crane starts small. A regular mobile crane, the kind that drives in on a truck, sets up the first few pieces. A concrete base, a short stub of tower, the cab, and the long horizontal arm. At this point, the crane is maybe a few stories tall, short enough that an ordinary machine can build it. Then the truck crane drives away, and the tower crane is on its own. Now comes the part almost nobody knows about. Wrapped around the crane's tower is a special sleeve of steel called a climbing frame. Picture a square metal collar hugging the outside of the tower with powerful hydraulic rams inside it. Hydraulic just means it pushes using pressurized fluid. The same basic idea as the brakes in your car, but scaled up until it can shove hundreds of tons upward. When the crane needs to get taller, something strange happens. The crane reaches down, picks up a brand new section of its own tower, and hangs it off the side of the climbing frame. Then the hydraulic rams fire. The entire top of the crane, the cab, the arm, the counterweights, the operator sitting inside, all of it, gets pushed straight up off the tower. For a moment, the top half of the crane is not connected to the bottom half. It's just floating there, held up by the climbing frame with an open gap in the middle of the tower. Let that sink in. The heaviest, most important part of the machine is hovering over a hole in its own spine. Then the crew swings the new tower section into that gap, slides it in on rollers, and bolts it into place. The climbing frame lets go, settles onto the new section, and the crane is now about 20 feet taller than it was an hour ago. Want it taller than that? Do it again, and again. Section after section, the crane eats its way upward, using its own arm to feed itself the pieces. That's why a crane in the morning can be noticeably taller by the end of the week. It's not being rebuilt, it's growing. But this raises a scary question. What keeps it from tipping over during the climb? Because here's the thing. During a normal workday, a tower crane stays balanced using massive concrete counterweights on the short end of its arm. The load on one side, the counterweights on the other, and the tower in the middle holding it all up like the post of a seesaw. The whole machine is a balancing act. But during a climb, that balance gets fragile. The top is disconnected from the tower. Everything is resting on the climbing frame. One strong gust of wind pushing on that long arm could twist the floating top like a weather vane. So climbing days are treated almost like surgery. Crews only climb the crane in calm weather, usually with strict wind speed limits. The arm gets positioned in a specific direction, so the whole floating top is perfectly balanced over the frame, sometimes with a tower section hanging on one side just to even out the weight. The crew checks the balance before the rams ever fire. Get it right, and the climb is smooth and boring. Get it wrong, and you're trusting a skyscraper-sized machine to a bad guess. And it works. Thousands of cranes climb like this every single year, all over the world, and you almost never hear about it. That's the mark of good engineering. When it's done right, it's invisible. Now, you might be wondering about the really tall buildings. The super tall towers, 80, 160 floors. A freestanding crane tower can only get so high before it becomes too wobbly, even with steel ties anchoring it to the side of the building. So for the giants, engineers use an even weirder version of the trick. They put the crane inside the building. These are called internal climbing cranes, and they sit in the building's core, usually in an elevator shaft or a gap in the concrete. Instead of growing a taller and taller tower, the crane keeps a short tower and climbs the building itself. Every time the construction crew finishes a few new floors, the crane jacks itself up and braces against the fresh concrete. The building goes up, the crane rides it like a climber going up a chimney. The crane builds the floors, and the floors hold up the crane, each one lifting the other floor by floor, all the way into the clouds, which is a genuinely strange loop if you think about it. The building couldn't exist without the crane. The crane couldn't be up there without the building. Okay, so the tower gets built, the last beam goes in, and now there's a new problem, and honestly, it might be the best part of this whole story. How does the crane get down? You can't just reverse a 500-foot climb and call it a day for the internal cranes, because now there's a finished building wrapped around them. And you can't reach the top of a super tall tower with any machine on the ground. The crane is stranded on the summit of the thing it just built. So engineers solve it with a chain. A smaller crane, called a derrick, gets carried up and assembled on the roof, sometimes lifted piece by piece by the big crane itself. Then the derrick takes the big crane apart and lowers the chunks down the side of the building or through the shafts inside. But wait, now the derrick is stuck on the roof, so an even smaller crane comes up and takes the derrick apart, and then an even smaller one takes that one apart. Each machine dismantles the one before it, like a set of Russian nesting dolls in reverse, until the last little crane is small enough to be broken into pieces the workers can carry into the elevator, or winch down by hand. The final machine leaves the building the same way you would, through the front door. Every skyscraper you've ever seen ended its construction with that quiet little relay race on the roof. Nobody films it, nobody talks about it, but it happened, hundreds of feet above the sidewalk, on almost every tall building in your city. And once you know all this, you start to see cranes differently. That thing on the skyline isn't just a tool sitting at a construction site. It's closer to a living part of the project. It arrives small. It grows with the work. It feeds itself pieces of its own body. It clings to the building it's creating. And when the job is done, it takes itself apart and disappears, one shrinking machine at a time, leaving nothing behind but the tower. Here's the part that sticks with me. We usually think of machines as things we build and then use, finished objects, but a tower crane is never finished. It's designed from the very first bolt to be incomplete, to change its own shape, to be mid-transformation for its entire working life. The engineers who designed it weren't just solving a lifting problem. They were solving the riddle from the beginning. What lifts the lifter? And the answer they found was almost poetic. It lifts itself. So the next time you're stuck in traffic and you see one of those yellow towers hanging over the street, look a little closer. Check its height. Remember it, because in a week, it might be taller. Nobody lifted it up there. Nothing ever did. That crane on top of the skyscraper climbed there by itself. And somewhere in your city, right now, one of them is still growing.